Today we are going to see the Kubernetes service practicals, right? So in the last session we had understood about uh, what are the different services where the Kubernetes provides, right? So it provides a cluster IP, NodePort, and the load balancer, right? So today we are going to see the practical, usage of how exactly we can use when it comes to services. But before that, let me give a some background about that. Like already we learned, but still I would like to give you again. So So here we have a Kubernetes cluster. You know very well. This is a Kubernetes cluster, and we we have a nodes here, master and worker node. So this is our master, right? So this is your worker node actually, right? So yeah, guys, can you unmute it? Yeah. So here what we have that we have a master and we have a worker. So let me write down here. We have a master. So we have a master, and this is we have a worker. Worker node one, worker node two. Right now, here, right, what we will do, we will try to create a two deployment actually. One is with the web server deployment, and other is a database deployment. Suppose I have a deployment over here, so I'll create a two deployment like this. This is nothing but your web deployment actually. Means basically I will use the deployment as a type. So here I'll be basically deploying the web deployment actually. So as we know that if we create a deployment, we will get the replica set, right? We'll get a replica set. And here what will happen, right? Let me do one thing. As of now, I'll only create only one pod actually. So this will be a one pod, right? And this would be your web server pod actually. Like suppose I am having a web server of Nginx. So here Nginx would be running up actually, right? Similarly, what happened, right? I have a one more deployment. This would be a basically a database deployment actually. Database means like you can have a MySQL or MongoDB or any of the DB. So here obviously we'll have a replica set. So replica set, and here you have right now I'm just creating. I'm not having the multiple replicas of the pod. I'm just having only one pod actually. So now this would be having a MySQL or any DB, something I'll take MySQL, right? Now you know very well that now suppose for example, whenever my web server, my application, it want to communicate with the MySQL, which is running in a different deployment, and it is running in a different pod actually. So now what you have to do that you have to just and each and every pod you know that you will get an IP address, right? 10 dot I'll just write it down here. 10 dot 100 dot 10 dot 11 something. This will be having something like 10 dot 100 dot 10 dot 12 something. So this IP address which is given for this pod, and this IP address which is given for this pod, and this here in this pod the Nginx is running, and here in this pod the MySQL is running, and both are different deployments, right? There are two deployments which are running. So now what will happen that actually that whenever the Nginx it want to whenever the Nginx it want to communicate with the MySQL, it can communicate the MySQL with the help of this pod's IP address, right? So basically what happened, right, whenever it want to do, so what happened, right, the ports, the MySQL ports IP address will be binded with this Nginx pod, right, or with this pod, so that this pod can actually communicate with the MySQL. It means that whenever any of your web server you want to pass any data to the MySQL, so that this pod will have to store any data to the MySQL. Right, the application will be running, but finally it want to access the DB which is running in some other pod, right? So then what is happening, that there has to be some kind of a binding, right? So this is the normal way, right? So now what will happen that, okay, sir, are you able to see? Are you able to hear? Ashish is saying like we lost.
Yeah, now it's fine, Rajesh.
Okay. I mean, was there any lag earlier?
Yeah, yeah, it's been breaking your voice.
Yeah, now it's fine.
Okay. Now then,
Yeah, now it's okay. Sometimes for a few seconds it will
yeah.
hang.
Okay. Okay. So now, so we know very well that the IP address of this MySQL has to be binded with your Nginx web web server, right, or the web pod, right? So here, wherever the web application is running, right, in this pod, it has to get binded. So this is all fine. Now what happened? Suddenly, assume that due to some reason, or actually what happened, that this MySQL will get, this pod will get terminated, or it get killed actually, right? It will get killed. So what we'll do, as you know, it will get killed. As you know that this replica set is going to create one more MySQL pod actually, or one more pod, which again has the same MySQL container which is running inside it. Now this will have a new IP address. We know very well now, right? We know very well that maybe, right, this will be assigned an IP address of 10.100.10.13. Some one more new IP address. Now what happened? All these days, this pod was binded with this MySQL, which is having the IP address 10.100.10.12. Now because of this pod is having some issue, it got terminated. A new pod was created. So now what you have to do is that, as a manually what you have to do, you have to rebind again this new IP address with this Nginx pod now, right? So here this is not a good idea, right, to do that always. So hence what is happening is that we came up with something known as a services actually. So what happened, right? We have a web deployment. So here I write it down. This is the web deployment. This is the web deployment. Okay. This is the web deployment, and this is nothing but your database deployment, right? DB deployment, right? So here what we will do, on top of this web deployment, we are going to create a service. So we are going to create a service. And as you know that we will be using a service of a type known as a ClusterIP. So whenever a service should be created, a ClusterIP, or a service should be created, automatically what will happen, that the Kubernetes will provide an IP for this, like something like 10.200.10.11, something. Similarly, what happened right here on top of this deployment, when you are creating one service which is of a type ClusterIP, ClusterIP. So again, the Kubernetes what will do, it will try to create a, or it will try to assign an IP address for this service. So 10.200.10.12, something. Correct. So now what is happening, that now what you say, that actually that here, instead of binding the pod's IP address to this Nginx, you can bind the the database cluster IP address to this Nginx, like this. So that you know very well that even though the pods will get killed or the plots will get terminated, automatically this replica set will create one more new pod. And that new pod will have a new IP address, and always this IP addresses, you know that it gets binded, or the endpoints will get binded with these services. So hence what is happening now, the Nginx, whenever it want to communicate with the MySQL, it will not directly communicate with the pod. It will try to send a traffic to this IP address, which is a cluster service IP address. So from here, what is happening is that, so it knows that actually Nginx is communicating with this IP. It means that it's going to send a traffic to this IP address. And later what happened that this is not my cluster IP address, and it has already added all the endpoints of the pods which are below running below the replica set is running. So it will try to forward the traffic to this any one of these pods. So always what happened right here from the outside, the traffic comes to this cluster IP, and from the cluster IP, it will come to a particular pod or some web server which is running. From here, if it want to communicate with the MySQL, the traffic goes like this, and again it will come like this. So this is how the traffic flows actually. And now you know very well that cluster IP we use because like whenever you want to talk within your cluster or within your nodes actually, then the cluster IP is used. Suppose any person who's sitting outside, he want to communicate with this pod actually, he cannot communicate with the pod with the help of this cluster IP because this cluster IP is it's like a private IP address which is given within this Kubernetes cluster. So this IP address will not be able to access by the outside world actually. So it will be within your cluster itself. So hence what is happening that you know that to overcome that, suppose suppose any person who want to access the pod which is running over here, he want to access means then he has to communicate to your NodePort. Which means that you need to create a service and service type should be a NodePort actually. So once you create a NodePort, what is happening that every node, whatever the IP address it has, right? Like for example, this suppose this is a machine, and if I say kubectl get ports get nodes -o wide, you could see that this is your master IP address. This is a master IP address, and this is your worker node IP address, right? This is a worker node. This is a worker node IP address. So now what happened? As soon as you choose the service type as a node port, so then what is happening that by default what happened, right? The node port, one IP address will be, sorry, one port number will be exposed actually. So you have to use always something 3248 some. The same port will be exposed even here, even in this worker node IP address also 3248. So whenever you're using a service as a node port, then this customer he always hits to this IP address like this. And from here you know very well that this will be binded with your cluster IP, and from the cluster IP the traffic will be flown and it will be reached to the pod actually. This is what we have discussed yesterday actually. But here what is happening is that we know very well that whenever you want to bind the whenever you want to bind the port numbers, you will not be binding always the pod IP address, you'll be binding the service IP address. Now here we are just taking one example. Suppose you create replicas of the MySQL, right? So a lot of MySQL pods will get created. Suppose you say that 4 pods has to get created, right? So what happened, right? 2 pods will get created here in your master node. Assume that 2 more pods will get created in your worker node, right? In your worker node, right? I mean, there is no control, right? The pods can get created anywhere, right? Within your, right? It can even get created in a master if there's a worker 1, worker 2, worker 3, right? These pods can be distributed between all the nodes, right? So that we cannot control over, right? Or unless and until you specify some label, or unless and until you bind the label along with your node, right? Along with the namespace, until that you cannot control, or else it has a free will that it can be created anywhere. So even this pods will also have an IP address, you know very well now that, right? This pod will have a 10.100.10.14, and this pod will have a 10.100.10.15. And you know very well that this cluster IP, which is but the database cluster IP, it will going to add all this IP address, this IP address, this IP pod's IP address, this pod's IP address, and this pod IP address. It will add all this IP address as an endpoint within it actually. That's how the cluster IP can manage to send the traffic between these pods. So this cluster IP will act like a internal like a load balancer itself. So how it sends and all, it is no, it is a that's how the service cluster IP works. Service works actually. So it internally uses some algorithm to to distribute the traffic between its pod actually. Okay. So now what we are going to do here is that today we are going to create two deployments. One is with the web deployment, other is a database deployment. And we will see like how we can assign a service of a type cluster IP and we can communicate with it, right? So that's how our lab would be today. Now, here what you have that, if you check it over here, if you execute kubectl get pods, you see that there are no pods are running. So what I will do, I'll say kubectl get all. So there are no deployments which are running in the system. So what I will do basically, I will put a watch on that actually. I'll just keep a watch on this. Okay. I can even say that kubectl hyphen o wide. Okay. Basically, I will keep a watch on this complete command kubectl get all. Okay. Hyphen o wide. So now what I will do here, basically, I'll go to the, I have opened one more same master instance. So here what is happening that basically I will go to, there are two different YAMLs are there. One is a web.server, you could see that, and other is a dp.server, dp-server.yaml. If you see, both the YAMLs are same actually. So now what we are doing that, I'm using the kind by name deployment. Okay. So API version is app v1. So where we'll get these things, we'll get in your API reference, right? We will get to know about what is an API version. And here what happened in the metadata, we are just mentioning the name and we are mentioning the label, correct? And here what happened in the spec actually, I'm using the replicas as one. Okay, fine. I'm just using only one replica. That is fine. Later I'll scale it to more than one actually. And here I'm using a strategy as a recreate. Okay, if you want, you can remove this. I don't want to have any kind of a strategies. I want to just create a pod actually. So I don't want to do it, but okay, let it be like that only, no problem. So then you have a selectors here, and in the select in the match label, you have to give the label as web server itself, and again in the template, you have a metadata, and here also under the label, you have to mention the label actually. So we know very well that whenever you're using the deployment as the as a deployment, when you're using deployment as a service, you need to have a spec, and inside the spec you need to have a replica strategy. If you want, you can keep it strategy, or else you can remove selectors, template, and spec. These three things should always be there. You know that very well, right? Selectors, template is there, and under the spec actually, here you are having a containers, and I'm using a simple basic nginx container here, and I'm using the image of 1.7.1 nginx image, and I'm exposing, and or else not exposing, I'm saying that this nginx container is using the port number 80. If you don't mention this port also, still the nginx will always use the port number 80, but I'm specifying it here that it uses the port number 80. So this is what the simple web server. It means that if you come to the diagram, so here what happened, I'm running an nginx image here. Okay. Similarly, what happened if you go to the db server, the same thing here, the same stuff here. I don't see any difference here, but here also I'm using nginx itself. I could have used the mysql image over here running. Okay, I can call the mysql, and I need to specify what's the port the mysql using. You know, the mysql will always use the port number 3306 is a port number, and I can also even have to pass some environment parameter as the password for admin password for that, but no problem. What we'll do that, we will use with the same example here also. I know we'll consider this as an nginx itself running under the even under the database deployment also. So we have a db server yaml and web server.yaml, correct, sir? So now what I will do, I'll just copy this file, copy this content. I'll go to the master. Okay, let me don't think, let me go here, and I will just say same thing. I'm use the same name. I'll just paste it. So I have a file, now the web server YAML, right? Similarly, I'll even have a database server, right? So I'll say nano db hyphen server dot YAML. So I'll go here and I'll open that database. So this also I'll copy the same stuff actually. The same thing. So I'll copy it and paste over here. So let me open and check it out. So now here what happened, right? You have a DB server. So let me do one thing now. Let me apply these two files actually, two YAML files. So I'll say kubectl apply -f web-server. So when you apply it, you could make out that here, see, because I'm just creating only one pod. See, I'm making as a one replica. It means that I'm running only one pod. Even if you see in a web server, here also I'm using only one itself. Later I can scale up actually. Okay. So here what happened, right? You could see that actually it has created with the name deployment with the name web server. And within that, you could see that it has created one pod with this name, right? And you know very well that whenever you have a deployment, you know that whenever we have a deployment, there has to be a replica set, right? So you could see that here also it has created a replica set, right? And if you see very well, right, replica set has a name known as a web server 67598. This unique, these are unique number actually. So the same for the pod name also while assigning, it uses the same name here as a pod name also, but after this it will use some arbitrary name here. Clear? And you could see that actually you have a desired of one pod running, and readily it is currently running as a one pod itself. And you are using your, it is running your image, this one. And this is what the selector, this is a label which is used by the deployment actually. So how it understands about each and every pod with the help of a label, you know very well, right? So this is what it is running. Okay. Now let me do one thing. Let me run kubectl apply -f and specify the db -server YAML. So now I'm just running this db -server YAML. Now you come back to here, and now you could see that it has created one more deployment with the name db-server. And it has created a pod with the name db-server. And also you could see that the replica set here we are having with the name db-server. So till here you are clear, right? So it has created the two deployments here in this example now. So now we know very well that actually that now you could see that these two pods are running. Now what you say that, okay, Rajesh, this is a web server pod and this is a DB server pod. Can this web server pod, because in both this pod, this Nginx image is running actually, correct? Whether both these pods, can it communicate each other? Suppose you assume that I'm inside this pod, sir. So being inside the pod, can I communicate to this pod or can I ping to this pod actually? Let's see whether I'm able to ping or not. So I'll go to the machine here. So what I will do here, I'll say kubectl exec, means I'm getting inside a pod, sir, actually, IT. And what I will do, I will get inside this web server pod actually. Okay, so I have to copy this. I'll say kubectl exec IT and then specify the pod names. Then you give -fn and say /bin/bash. So you are inside the pod now. See, you are inside the pod. So you are inside this pod now. Correct, sir? And you could see this is IP address, sir. If you want to print the IP address, what is IP address? So you can execute a command host name -i. It will print the IP address. Clear, sir? Now what I'm doing that from here, sitting here, I want to ping to this machine actually, or I want to ping to this IP address. Let's see. See, there are two ways to check the connectivity. Either you can ping to this IP address, or else you can run a curl command to this IP address. Okay, this is so curl command. So if I execute the curl command and specify this IP address, see, okay, curl is not there. So I'll do one thing. I'll install the curl apt get update. Let me update it. Okay. Could not verify. Some error is coming, sir. Again, I'll run it. Sudo is not required. App get update. Where to fetch? Okay. Let me see. App get install curl. Okay. So this will take some time, but okay, that's fine. Because I basically need a curl command, right, to just verify if I'm able to reach out to that other pod. Okay. Okay. Yes, it's happening. So it is installed now, right? So if I execute the curl command and specify the IP address of your DB, okay, now you could see that I'm able to get it. It means that you are able to access the application which is running in this pod. Inside here, what is happening? The Nginx is running. So what are the default Nginx pages there, right? That is showing up actually. Even you can even ping also. Ping 10 dot like this also you can ping it. Just to verify you are able to reach out. It means that from your from this uh, pod, you're able to connect to this pod actually. So just we checked it out with the help of a curl or even with a ping also. Okay, sir. Now the question here is that actually, okay, fine, sir. It means that basically you have binded the IP address of your DB server into your web server. Now assume that this pod has got killed actually. So you are able to do a curl command, curl on this actually, right? Now assume that, let me do one thing. I think I have one more, this one master. So I'll do one thing. I'll go here and I'll try to kill this actually, or I try to delete this pod actually. See, kubectl delete pod and specify the pod name. Now you could just see, to just observe what is happening here. See, I'm just deleting, and you just see here that it will lose this IP address, and one more new IP address will come actually. Could see here. See what happened? Kubectl delete pod. Yeah, I think I didn't copy it properly. I'll copy this completely here. Now I'm just killing that pod actually. See, the pod is getting terminated. See, deleted pod. What happened, sir? I think. Oh, okay, okay. Oh, it has assigned the same IP address. Okay. I thought it will usually it will assign the other different IP address like 10.32.0.4 or some other IP address. It has assigned the same IP address actually. So maybe because of the scarcity of the IP address, it is not giving any other IP address. So I'll do one thing. Let me delete one more time. Or let us see. See, you could see that here BWP79. The last is BWD79. And we could see that it will create a new pod. See, a new pod will get created. This is getting terminated. Oh man. See, a new pod will got created, but again the same stuff. Okay. So here what is happening? That same IP address getting assigned, but when we do it, when we are doing, usually what happens, right? A new IP address will get assigned actually. So here what is happening? The same scenario, right? If this IP pod will get deleted or terminated, a new IP address will be assigned. Now you cannot bind it to the same Nginx or to the same pod where the Nginx is running, right? So there you have to do it manually. So you shouldn't do it. For that reason only, you need to create a cluster IP, cluster IP actually, as a service as a cluster IP, right? So here what you are doing here, okay, this is fine here. So okay, so now what I will do that now I will try to create a service with the name cluster IP. So you could see here that, so here what happened, right? There are no services there. This is only one service. This is a default service which will be there always in the system. So we will discuss this later on. Now when I create a service, you could see that one more service will get added up. So what I will do, I will create a service for your DB actually, for your DB server. Okay. To do that actually, what is a command you have to do? You have to say kubectl. So let me clear the screen. So kubectl expose. There are two ways, sir. Either you can create with a YAML file, the service, or else you can even create through a command line. So if I execute kubectl expose, right now I'm showing in the command line deployment. Okay, and what is the deployment name? db-server, db-server. Here, the same deployment you have to use the name here. So I'm using the db-server, right? So db-server space. What is the type you are using? Either you want to use the cluster IP or NodePort or the LoadBalancer. So I'll use a cluster IP. So always here, C should be capital and IP should be capital. This is always okay. Hyphen hyphen with what port you are using? to which port actually. So it means that when you're creating a service here, when you're creating a service here, you have to provide what is the port to which you are binding actually. Here what happened, right? You whenever your port, right? When you're creating a service, you need to even specify the port also. So this we call as a front port actually, front end port. This we call as a back end port. Back end port means here, from here, how it can actually communicate with the below pod actually. So that we call as a back end port actually. And we know Nginx, rather web server will always be running on the port number 80. So in the front end also, I can specify some port number 3316 or any other free open port. But what I'm doing here that I'm using the again the same port number 80. Okay? Hyphen port 80. Okay, space and hyphen target hyphen port is equal to, and the target also I'm mentioning the same. So let me explain. kubectl explain expose deployment, specify the deployment -fn type is cluster IP -fn port 80 space -fn target -port is equal to 80. It means that here also the target port also I'm mentioning 80 only because obviously here it is running in the port number 80. So here in the front port also I'm mentioning 80 only. I can give any other port, but still I'm giving only 80 itself. So let me have communicate with the 80 port itself. So it's enter. So you could see that it has created a service actually. Now if you come over here, now you could see that a new service has added with the name cluster IP for the type, and this is the IP it is provided. It means that now what is happening that this is the IP address provided. So if you go to the diagram here, so I could say earlier I was saying that 10.12. It is not that 10.12. Now it has given some IP. So this is the your service IP. So what is the service IP now? This is service. So this is the cluster IP which is provided. So this is the cluster.
Rajesh, DB, right? DB service, right?
Yeah, sorry. I think here. Here. Yeah, here. So it has provided this IP address. Correct. Now what you can do here that even you can even access the what is happening is that actually even what is happening, you can even run the curl command onto this IP address also. So now what it is happening is that actually basically as soon as I create the cluster IP, what has happened, whatever the pods which are running below, right, that those pods have been added as an endpoint to this cluster IP. Now, if you see that, if you go and if you describe this cluster IP, right, suppose if I go over here and if I say kubectl describe service, specify this service name. See what will happen? See what it is showing? It is showing us that here the cluster IP is nothing but 10.108.239.92. Fine. Okay. And it is a cluster IP type. Okay. And you could see the end-point. What is this end-point? 10.30.0.3. So this end-point is nothing but this pod, right? So DB pod here which is running, right? 10.32.0.3, right? See, this has been added. And it is running onto the port number 80. See, automatically what happened, right? On top of this cluster IP, service IP, right? The endpoints have been added. Because here I have created only one pod. If you see, I've just created only one pod. I don't have replicas of the pod. So hence what happened, only one IP is added. Now assume that if I open the DB-server and I will create a replicas actually. Instead of having one replica, I will have four replicas. Now I'll say kubectl apply -f db-server. Now you could see that if you go here, see, now you could see that there are four pods of your DB servers are there, right? DB-server, see, and the IP address are the same, 4, 5, 6, right? Now if you come here and if you execute a command kubectl describe service under services, now you could see that all the four IP address 1, 2, 3, and 4. All the four IP address has been added as an endpoint within your cluster IP. Correct, sir?
Yes, Rajesh.
Yeah. So now what is happening is that actually that now if you know very well that now if you now you could see that actually that if you this is a cluster IP, right? Cluster IP. If I go to this, so I'm inside the see I'm inside your pod actually. Now if I say curl onto this IP address, see, see you're able to access. It means that as soon as you're hitting this IP address, this is the cluster IP address, right? This is a cluster IP address, service cluster IP address, right? So what happened that the traffic should go to the pod which are running below this cluster IP, right? Because all this. So that's what happened, right? When you do a curl, being inside your web server, I'm doing being inside this web server pod. I'm just doing a curl onto this. I'm able to access any of the DB which is running under these four pods, right? So this is what we can. It is it is sure that actually now we are able to communicate from the web server pod to the DB server pod, correct? So now why we need a service? You know very well that even though one pod will get deleted, a new pod will get created. So here what happened, this pods, right? The web server pod, it need not to bind any of the pods which are, it need not to bind the IP address of this pod. Basically, it has to bind the IP address of the cluster IP. That's what, right? Because this cluster IP will never go. This always be fixed actually. Unless and until you delete the service, it will not go, right? Similarly, what is happening is that you can even create a service for your web deployment, right? Right now, you're only created a service for your DB. Similarly, you can even create a service for the web server, right? So how to do that? Same thing. Go here, kubectl, expose deployment web hyphen server hyphen cluster or hyphen type is equal to cluster IP. So here I need not to mention anything as a target port and a port. So it will take the by default whatever it is there. Here, if you come here, you could see that it has created a web server. See, it has allocated a IP address for this service. So this is the service IP address. If you come here, so this is a service IP address for this cluster service IP address. Right here. Right. So now what happened whenever an outside, whenever any person who want to access this pod which is running here, so he will come via the node port. But here what happened, right? Here this node port will have always it will send a traffic to this cluster IP address, right? So now you know very well that actually now if you see it here, like just to show an example, if you execute the kubectl describe service and specify this web server. Now you could see that this IP address is already added 10.30.0.2. So what is this IP address 10.32? It is nothing but a web server IP address. See, when I described this web server service, it has added this IP address as an endpoint within it. Correct, sir? Now, if you say that Rajesh, okay, fine, you do one thing, I'll do one thing, just a small experiment. Like I will use a describe DB server. I'll do a watch on this actually. Watch on this. Now you could see that actually I will create one more duplicate session. So now you know that if I delete any of the pod, specify any pod name. Suppose I'll take any pod name over here, some pod name. So right now not execute. You just see here the behavior of this. You could see that it'll you could see here it'll get deleted one data one entry will get deleted again one more new entry will come, right? See? Oh, it is so fast that see it will get deleted one more new data one more new IP address will get added up. So it means that whenever you are deleting or whenever any pod is getting terminated, automatically the replica set will create a new pod, and that new pod IP address will be added with your cluster IP, right? With this service actually. This is very important, sir, which you have to know. So hope that you have understood everything, whatever I have said till now. So it is very clear now that how exactly the service IP, which is cluster IP type, works, right? So now whenever I want to delete the whole stuff, what I will do, I will just say here I'm deleted. I have to delete the two services, DB service and the web service. You know very well that I have to delete it. How I have to do that? I check kubectl delete service and specify your kubectl delete service and DB server. So to delete the deployments, we know very well that we have these two files. I will say kubectl delete -f.
Can you show one deployment with YAML file?
Hello.
Can you show one YAML with one YAML file, Rajesh? With YAML deployment service one.
Service one. Okay. So we have a web service, right? We have a web service. So here we have deleted the web service, right? So here you can go here. So you can copy this. I can say that web service.yaml. Now you could see that actually here it is using the select as a my app, but here what happened that you have to give the web server, right? So
inside deployment, we cannot use this one.
inside deployment also we can do. We can add this section under inside deployment. I'm just creating a different another deployment.
Okay.
Sir, somebody can mute, sir, actually. Yeah. So I'm creating one more deployment, so a separate deployment over here. I can add the same thing in the existing deployment itself, because both the deployment as well as service will get created in a single file. But okay, I'm just showing it here. So here what happened that, and the target port it is showing is a 9376, right? And here the front port is 80 actually, and here you are giving select as web service, and you're creating with the name my service as your service name, and you have to use the kind as a service here. So these are the three important things you have to note down whenever you are creating a service. So now here save it actually. So if you see the web service, sorry, if you have a web service, web-service YAML, right? Yeah, we have that. So I'll apply it actually. kubectl apply -f specify this web service. Now you could see that actually it has created with the name web service. See here, the cluster IP is assigned here, like this.
Okay, got it.
Yeah. So I will delete it. kubectl delete -f web-service.yaml kubectl delete -f. I have to delete the web server.yaml. So if you delete everything, now you could say everything is deleted, right? See, even all the pods, deployment service, everything I have deleted now. Now, but if you see it actually that when I execute the kubectl get all, see here, whenever I execute a command kubectl get all, see we run this command basically to show what are all the current deployments are running, what are the current replica sets are running, what are the current services are running, all those things to showcase everything will run the single command, sir, actually. But when I execute this command actually, it is showing that already there is a service with the name Kubernetes, sir, and it is of a type cluster IP, and it is having an IP address of 10.96.0.1, sir. Now in interview they might ask, many times they have asked even this question, what is this actually a service with the name Kubernetes? So by default there will always be a name with the name Kubernetes, right? There will always be with the name Kubernetes, but what exactly is that actually basically? So what I have to do that actually, we have to say that this by default will get created when you are when you're making the master node up, right? When you do a kubeadm init, right? So what happened, right? Basically, there are many pods are getting created actually. So if you execute the command kubectl get pods, and it'll say that there is no pods running in your default namespace. But if you check kubectl get namespace, you could see that there is a namespace with the name cube system, right? Now when I execute kubectl get pods -n, specify this namespace actually. Now you could see that these are all the different pods which are running this namespace. Now if I do a -o wide, let me check the IP addresses. See, can you see some of the pods are having an IP address of 172.31.81.9. You could see that some of the IP addresses are having this, right? Now, what exactly happens, right? All the pods, right? All these different pods, they are communicating via with the help of the service, sir. So very important, sir. And this IP address is nothing but this is the IP address of your master node, sir. Actually, if I execute if config, uh, if I execute if config, your master IP address is what? See, 172.31.81.158. See, this is your master node, sir. Actually, it means that these pods, all these pods are running under this master node. But to communicate between this one pod to other pod, it always uses this service Kubernetes. This always it uses this service. Always uses this service. Now, if I execute kubectl describe service, and if I say the name Kubernetes, now you could see that. See, the endpoint it has added is the IP address, and it is with the port number 6443. See, and the IP address of your what is the IP cluster IP assigned? See, cluster IP is 10.96. This is a cluster IP, right? And this is the endpoint, sir. What is this endpoint? This endpoint is nothing but all these pods, right, which were running, right? Where is it? See, see, these are all endpoints, right, sir? These endpoints are nothing but these are the IP address of your master node itself, where these pods are running. These are all the system pods, sir. Whenever you have to say that whenever the system pods, if they want to communicate each other, they can communicate with the help of a service with the name Kubernetes. Even you can delete also, sir. Like for example, if I execute watch on kubectl get all. See, I'm watching it. Let me do one thing. Let me go to the other terminal. So I'll say kubectl delete service and specify the service name Kubernetes. See, it is getting deleted. Again, it will recreate it. See, again it will get recreated. See, again it has recreated. So this is very important, sir. In an interview, they might ask you what is this default service with the name Kubernetes, which is always it will be up and running, or it will always be there in your system. You have to say that this is the service which is used internally within the system pods or within your master. There are a lot of pods are running, right? To communicate within those pods, it needs some service actually. Clear?
Yes, Rajesh.
Yes,
Okay.
sir. Yes, sir.
Yeah. Okay. Now what happened? Next we have a NodePort we have, right? NodePort. So now what has happened, that as we discussed already, that this with the help of the cluster IP, any person who is sitting outside world, he cannot communicate with this cluster IP, correct? So he has to have, so whenever he want to communicate it actually, then he has to communicate with the help of a service with the type NodePort actually. So whenever you are creating a deployment and when you are creating a service of a type NodePort, what happened, right? Automatically, whatever the IP address is there here, the system IP address there, right? The node's IP address, a unique port number will get exposed actually, and the same port will be exposed in all other nodes within your Kubernetes cluster. So what happened that whenever the outside person want to communicate, who's outside the Kubernetes cluster, want to communicate, he can hit this IP address to this port number. So now what I will do to showcase this example, so we will do the same thing, sir. We will do the same example I'll take. I will not take any other example. Like I will use the web server itself. we have web server.yaml file, right? So I'll do one thing. I will, instead of having one, let me create two replicas actually. So let me create two replicas. I'll save it. So now what I will do, I'll say kubectl. I'll say apply -f and specify the web server.yaml. You know that it will create a kubectl get all. Now you could see that it has created a deployment with the name web server, and you know that it has created two pods because you are given the replicas of two, right? So, and if you're still you want to check the IP address, I can say -o wide. Okay? You could see that these are the IP address of those pods which are got created. Clear, sir? Now you say that Rajesh, I want to access this port outside that outside the Kubernetes cluster. You say that okay, no problem. You create a service of a type NodePort actually. So now how to create a NodePort service? You have to say same command. You have to say kubectl expose deployment. Okay, what is the deployment name here? So the deployment name here is web server. For the web server, you are creating a service. So you have to give export kubectl expose deployment. The same things are even you have a command line as well as you can even create it with the YAML file also. So kubectl expose deployment web server space and specify the type -FN type is equal to node port. Suppose you're doing a mistake, sir, no problem. Suppose you're doing like this. So if you're doing like this, yeah. But one thing you have to always remember that, sir. One thing very important that suppose already if this deployment is having one, already it is having one, one service it is already having. Suppose assume that this deployment is already having a cluster IP, then you cannot create one more service, sir. Always for each and every deployment there will be only one service, sir. You cannot have more than one service. That you have to keep in mind. So suppose assume that if I create here the cluster IP as a cluster IP as a service type. So cluster IP I've already created, right? Now the cluster IP is running here. Correct, sir? Cluster IP running. Now you say that Rajesh, I want to create a node type actually, as with the name NodePort actually. Okay? So it will throw in error. Already exists with the name. So you cannot, it will not allow at all. So that's the reason you should always have only one type actually. Okay? Now you say that I will create a NodePort as of type actually. Now you could see that actually here you have to give capital N and the capital P here, right? Whenever suppose you don't give it actually, suppose you give a small thing like this, so it will throw error. It say that the unsupported value is the valid supported cluster IP, external name, load balancer, and NodePort. See here it should be capital N and capital P. So I have to change this like this. So when I do it, so it will create, you could see that it will create a NodePort, see, of a type, okay, NodePort. But you could see that actually it has even given the cluster IP also. So that's what I said that when on the last session also, whenever you are creating a NodePort as a service type, automatically it also assign a cluster IP also. So that's the reason you could see that here it has assigned the cluster IP. And here what is happening is that it has exposed what it says that what happened right here 31829, that this is the port which has been provided. So instead of 32148 it is 3189. And then what is happening that here what happened when you are hitting this to this 3189, automatically it has to redirect to the below service which is running, which is using the port number 80. Okay, so now what is happening that you are having a 31829. See here, come back here. If you come over here, so this is having a NodePort actually, okay, but this NodePort is assigned, that is fine. But what happened, right? Now here what happened, right? You are having the master and the worker actually. Here what is happening that you have a private IP and the public IP. If I say private IP, I cannot use the private IP, sir, with that port numbers. It will not work out like that. Okay? 31829. will not work, right? Because it's a private IP, right? So I have to use a public IP. So I have to use a public IP here. So what is that? 31829. See, run this. See, you are able to open the executable. Similarly, what happened is this is your master. So let me go to the worker node and let me take the IP address. I have to use the public IP itself. I'll copy it and I'll say I'll assign the port number 31829. It's going to it will going to load here because you're below you are running the Nginx, right? It will open with the default web page. It's going to open. Correct, sir. So you could see that actually you're able to run it here, or else what we can do here that here there are two pods are running, sir. So what I will do, I will go here. I'll say kubectl exec -it and specify that pod name -fn /bin/bash. So whenever you want to get inside a pod, you have to give this way. So you're inside it. So you are into the this page. So this is the default Nginx page. So let me do one thing like I'll say echo welcome to pod 1 related to index.html. Yes, sir. So I'll exit it out. So again here also I'll get inside this. So kubectl exec -it specify that pod /fn/bin/bash. Some people will give like this directly bash also like this. Okay, some people will not use -fn, just say /bin/bash. This is fine, but this is deprecated now, so you have to use the -fn actually. /bash. So you are into this. So I'll say same thing. Echo welcome to pod 2 actually index.html. Sir, I'll exit out. Now let us see, sir. So welcome to the pod 1, and if I do this one, hopefully see it is reacting. Now you could see that, see I'm hitting miss, it is doing a kind of a load balancing, right? From here what happened, right? One request is going to one of the pod and other request is going to the other pod. That's what you can differentiate very easily here, right? See, you could differentiate very easily. See pod 1 here, see you go to the pod 2, right? Correct, sir? But again, what happened right here, what happens here is that actually whenever you are telling your customer to access your application by hitting this IP address with this port number, it doesn't look good actually, right? So you have to either you have to give you have to provide an IP address where you shouldn't provide any kind of a port number to be exposed. So that's the reason we use the load balancer actually. We use a load balancer, and as I said earlier, load balancer I will tell you later actually. But what we have to do is so same thing. What you are doing it here that the same deployment is running. So let me delete this deployment. So I'll say kubectl delete service, and the service name is web server, which is of a NodePort actually. So I'm deleting it actually. So again, what happened that I have to use the load balancer as a like as a service. I'll say kubectl expose deployment of a type web-server. Okay, and you have to use -fn type is equal to load balancer. So if I do it, you could see that actually it creates a load balancer and it is assigned the cluster IP address. But here what happened, the external IP address, it is still pending actually. Here what happened, that I should get one public IP address actually. So because like I need to get a public IP address, with the public IP address, if I hit that public IP address, then what happened, like, so I will provide this public IP address to that customer here who's sitting over here. He can hit to that IP address and automatically what happened, right? The request will come to the pod actually, or request will go to the application which is running inside the pod. So here what is happening, that there are many things are there to configure everything. I tried a few of the things, it is not working. So even like I will set up my own load balancer and check it out now. So by next Wednesday, next class, right, I will be able to give this example for you. So this, see, still it is showing the pending, because what happened, it is trying to search for any kind of a load balancer is configured in your Kubernetes cluster. There's no load balancer being configured, or even like this nodes have not been added to the load balancer as a target. Hence, what happened, right? It is unable to provide the any of the external IP address. Or else you can use the metal LB load balancer, or else that is what it is. So I will show in the next class, right, how exactly you will get this external IP with the help of a load balancer. Okay, with the help of a load balancer. Plus, what happened, I will explain you about the Ingress load balancer also, how internally the Ingress load balancer work within your Kubernetes cluster. So this would be this would be pending stuff from my end. So I will be explaining you in the next session actually. Okay. So this is all about the services, sir. Actually, clear, sir?
That's right.
Okay, sir. Great. Yeah.
So
So
basically,
now, yeah.
whatever IP is coming, that IP we are going to add to the Route 53 or somewhere DNS. Then
Yeah. No, that
so,
IP address we are not adding, sir. This is not, we are not adding this one, sir.
no. This one external IP what it is pending. It is.
Yeah. Extra API. What happened, right? Automatically, what happened? That's what. If suppose this whole cluster, it is in your Google Cloud, or is it in AKS or EKS? Automatically, that EKS or Google Cloud Kubernetes service, right? It will automatically generate a IP address and it will assign to it.
Okay.
Or else, suppose you are using your own load balancer. Suppose I'm using my own HA proxy. There, what happened? You have to give the range of your public IP address. Within that range, it will pick one IP address like that.
Yeah.
So I tried that also, but somehow it is not picking actually.
No, I got it. So what I'm asking is, once the external IP has been assigned, so this external IP we are creating the Route 53 entry.
Correct. We have to create a route for it. Yes.
Yeah. So that is we are generally become as a URL, web URL.
Yes. Correct. Here, what happened, right? You are going to create here. Here, what you will do, you will create a DNS entry. So basically, in AWS, we will have a Route 53, right? So here, what happened? Whatever the IP address, suppose assume that it has given an IP address of 54.172.14.7 something, right? So here you will add this IP address with the record A and specify something like www.mycloud.com. Like this, you will add the IP in the Route 53 actually. So now what happened, right? Always you will give this URL to the customer actually.
Okay.
So this is going to, the customer is going to hit this URL, and this here what happened, it will come here. Oh, it understand, okay, this is IP address. So it knows that actually there is already you have a load balancer here. So you're having a load balancer which is having the same IP address 54.172.14.7 actually. And this load balancer, these two IP address, right? The server's IP address have been added here. These two IP address have been added to this. So it knows that where to send a traffic like this.
So again, this one again it create the as well as NodePort and then again cluster IP.
Yeah, same thing, sir. Cluster IP has to create NodePort because you need to expose a port, right?
Yeah.
So the port has to get exposed. Everything will be happen again. So it doesn't. So whenever you are creating a NodePort or the cluster IP or the load balancer, automatically the cluster IP should also get created, sir. Automatically, that is required actually.
Okay.
Yeah. Okay, sir. That's all. So this finishes our. Finishes means cluster IP and the NodePort we have finished it, and the load balancer is pending, which we'll do in the next session. Okay. So services is over as of now. Okay. So what we will do that we will start up few of the topics now. So like we will start with the. We will start it now, or we'll start in the freshly for the next session. If you're okay, if you give me half an hour time, I will finish the Init-Container actually. Very.
Yeah, Raj, we can continue another half an hour.
Okay, sir. Okay, great. Now, so okay, let me open the notepad. Where is it? Are our K8 notes? Okay. It is day 13, right? Today. Okay. We have some important topics, like we have some Init-Container topic, and we have a multi-container, which means that you need to run a multi-container within a pod. So we have multi-container pod, as well as we have a Kubernetes volume actually. So these are very important things. So probably in next session, we would be covering the multi-container pod as well as the Kubernetes volume. But both these topics are little huge actually. It will take around one hour, but we will see how I can do it actually. Okay. So when it comes to the init container, so init is a very important, sir, actually. So in most of the time in intro also they have asked many times what exactly the init container actually. So usually what happened, right? For example, uh, I'll go with the diagrammatic format to understand what is init container actually. Now here, suppose you have a Kubernetes cluster here, right? You have a Kubernetes cluster here. You have a master and you have a worker node actually. Now assume that actually that you need to create some pods actually. Like for example, I want to create some WordPress. I want to run some WordPress. So we know very well that whenever I want to run a WordPress, I need to have a database also, correct? So for the WordPress, what you will do, you will say kubectl run, okay, something like WordPress fn image is equal to WordPress something, right? Similarly, so when you do it, when you run this command or when you execute this command, what will happen usually that it will create a pod, and inside a pod, you know that actually that uh, inside the pod, you know that inside a pod, it will create a WordPress container, right? WordPress container is basically an application. It's an app. It's an application, right? It's a web server. So now what is happening is that actually now to run this WordPress, always it requires some kind of a DB. So if you see the DB, you need to have something like a MySQL. So I'll do one thing. Let me create one more. Sorry, let me run one more image with the name MySQL. Right? If I say kubectl run, sir, kubectl. Okay. Run db-server -image is equal to MySQL 5.7 something. When you run this command, what will happen that here with either in the same node or in some other node. So what happened that one more pod will get created, right? And this will have a MySQL image running inside the container. So now what happens that actually that now whenever the WordPress, this pod, whenever the pod should be up and running, always it expects that the MySQL should always be there up and running. So before the WordPress comes in, you have to make sure that you have to have a MySQL pod up and running, so that whenever you are initiating or whenever you're creating a pod which it has to have a WordPress, it automatically checks that, oh, MySQL is up and running. It will try to connect to this MySQL with whatever the IP address is provided to it. So this is a normal scenario. Now assume that actually that this this MySQL pod is up and running. Due to some reason, this goes down actually. This goes down actually. This pod goes down actually. And afterwards, later, what happened that you are going to initiate or you are going to create the WordPress. Now what happened that the WordPress will get created, but while creating actually it's going to check whether the MySQL pod is there or not. It's going to check whether the MySQL DB is there or not. It checks and checks, it will go on to retry checks, it will go and try to reconnect for 20-30 seconds, and then it will give up, and then what happened, this pod will also goes down actually. Is there any way where before this pod comes up, I need to do a pre-check whether the MySQL pod is up and running? To do that actually, you have something known as an init container. Init container. So what this init container will do that actually, init container will make sure that before the main container comes up, what are the prerequisite this main container is required. Like here in this case of MySQL, right? It is going to check whether this MySQL service is up or not. If it is up, then only it will allow the WordPress to come up. If this init container if it checks for this service MySQL, if this MySQL is not up, it is going to check. If it is not up, then this init container will not allow the WordPress to create, or the WordPress port to, or WordPress port to come up actually. So the main usage of the init container is that it always does some kind of a pre-check actually. It means that before the main pod comes, what are the prerequisites it requires, that has been taken care by your init container, sir. Did you understood, sir? What is exactly the usage of the init container, sir? Sir?
Yeah, Rajesh bhai. Got it.
Yeah. So that is one use case, or else, for example, one more use case is there, something like suppose assume that actually I mean one more use case. Suppose, for example, like you have an Apache pod actually. You have a pod. Uh, you have a pod which is having some Apache service running. Now, what is happening that always this Apache service, right? It needs always some kind of a content actually to display, right? So you might have one more container or one more pod, which is nothing but it is going to always generate the. It is not, but it is a content generator. Content generator. The content generator. It means that always this pod will always be generating content, and that content will always give to the Apache, so that the Apache can display whatever the content which it gets, right? It can display, right? Now assume that actually that now what is happening is that actually now assume that this content generator is not working properly. This Apache cannot display any of the content, right? Or it doesn't, or else assume that in within your within your pod, right, you can even have a volume, you can even create a volume also. So later we'll check what is a volume. So in the next session we'll be taking, assume that, just saying that you are creating a volume actually. So what will happen that actually this content generator, right, whatever it generates the content, actually what happened that it will try to write all those data into this volume. So now what is happening that this volume again, it has been mounted to your Apache. Means that this, it is mounted to your Apache. So this has been mounted to your Apache. This is mounted to your Apache. Like this. This is mounted to your Apache. Now what is happening is that always what happened, right? Your Apache will always check whether there is any data into the volume or not, data into the volume or not. Then not to display the content. But what is happening that to get the data again into the volume, what happened? This content generator will be keep up and running. So now what is happening is that to check whether to do all those things before the Apache is generated, actually, what is happening that you will have one init container, sir. You will have one init container. So when you are having an init container, and that init container, what will do? It will just check whether this content generator is up and running, or whether it is generating content. It means that it is going to even check whether the data is being created by the content generator. Even this container can also check whether there is any data in the volume where it has been sending, or where it is actually putting all those data in the volume. So the init container can also check if there is any data inside this volume. So once it checks that if there is any data in the volume, okay, it is data in the volume, then only what happened, right? It will allow this Apache container to come up. If this is not getting up, and if there is no data in the volume, the init controller will make sure that this Apache will not get created at all. It means that this pod will not get created at all. So that's what it will check it actually. So this is also one of the use cases actually. Okay, right now I have told you some two use cases about where exactly the init container comes, right? So now, if you see an example, I think I have took the example of here itself, sir. I think in the net itself I have took, sir, actually. Okay, so if you go to the Google, and if you say Kubernetes init container, right? You can go to the official document. Here they have said the same thing. The pod can have multiple containers running within it, but it has to always have one or more init container which are running before the app containers are getting. So before the main containers are getting created, okay, there has to be an init container which always checks certain things. So init container always exactly like a regular containers. Init container always run to the completion. Each container must complete the successful before the one starts actually. It means that before the main container starts, the init container should complete its task actually. So if you come over here, you will have an example over here. So I think I have the same example. I have copy pasted the same example here. So now what will happen that if you see it here, I'm creating. So it's the same YAML file where you're using where you are creating a pod actually. So that's how we say the kind as a pod. You are having a metadata and you are specifying what is the pod name, and also you're specifying the spec. Within a spec, here you're creating a container. But you could see that you are having one more section of the init container actually. So this is the complete YAML file, sir. If you run this YAML file, what will happen at how Kubernetes will do that? Kubernetes is going to first initialize or check whatever all the containers which has to get created, which are there within this init container section, sir. It will not create this container. It will not create this container. What is there in this section? It will not create this container, sir. It will always create this container, sir. Right. So now what it is doing here, init container, you are having something like name as init my service. Okay, fine. Image is busybox of 1.2, and it is running some command. Okay, it is running some command. What this command means, it is trying to check until the nx look up to the service. It means that basically it is waiting for some service, sir, some service. Okay, do echo waiting for a service sleep for. It means that what happens that every 2 seconds, right, every 2 seconds, this ns lookup will look for this service, sir, whether the service is there or not, whether the service is there or not. If it is not there, it will be in a waiting state. Similarly, what happened, right? After this one container, one more container is there. This container name is init my service. Okay. This container name is init my db. Okay. Now what is happening that here also same thing. You're using the image of busybox. Here also it is doing the same thing. It is doing the ns lookup and is checking with the name mydb as a service, and it is checking for some service name. And every 2 seconds it is checking actually. So it means that actually, basically, before your main container is getting started, this init container is checking for some service to be available. If those services are available, what happened that this init container will suffice the need. It will check for the service. Oh, the service is there or there. Yes, it is fine. So this container will get terminated, and later what happened, right? Your main container will get started up. Suppose assume that this init containers, it is expecting from service to be there. If the service itself is not there, then it will not create this container at all, sir. This container will be in a waiting state. Sorry, this pod will be under the waiting state actually. Okay, so it will not create at all like that actually. I'm sorry, sir, not pod, container. Sorry, container will not create this container at all.
Right.
So now what will happen that you can copy this. Okay, I think I have to remove all the things. kubectl, delete. What is the service? Delete. And what else? Delete -f web-server. Everything is deleted, right? Now what I will do, I'll say nano. I'll just say init-container.yaml. Okay. So I'll just copy this file. I'll just copy this file and I'll paste it here. Okay, sir. Then I will save this file. Okay. So now what I'll do, I'll take kubectl apply -f and specify the YAML file. Now you could see that the pod is got created. Now if you execute the kubectl get pods, now you could see that it is showing as an init status as 02. It means that there are two no container within the init container section, right? It is there, but none of them got created actually, and even your main pod also has not created, right? If you do a kubectl describe pod, specify the pod name. What is the pod name, sir? Here, specify the pod name. What is the pod name? By pod actually. This is a pod name. Now you can see very carefully, sir. Now you could see that it has created the init my service. and it has just started the container, right? That's what, if you see in the this one, right? Now here, if you come up here, now you could see that the output is from here, right? So it says that, okay, the name of the name of this pod is my pod. Okay, fine, my name, my app hyphen pod. Okay, now you could see that init container. See the init container. The first service is init my service here. See? Init my service. Okay, this is a container. So what is happening, that it is in a running state actually. It is in a running state. Okay, it is trying to mount, it is trying to access this service actually. Okay, but any one of the containers should always be in a running state, sir. Okay, okay, after that what happened, right? You could see that init my db, see init my db, what is the state? It is waiting state. Why it is waiting? Because when this init my service will get terminated, sir, then this will get started, sir. Now you could see that it is in the state of the pod initialized actually. See, so what is happening, that if you see here init my db, this is the second container. It is not in a running state, it is in a waiting state, sir, actually. Again, why? Because that if this itself is not completed, how this can run actually? So that's the reason it will be in a waiting state actually, and it is a reason pod initialized actually. If you come down here again, you are having your main container, my app. Yeah, see my app. What is the status of it? My app. See here also it is waiting only. Pod initialized. Why? Because right, when these two pods, whatever the when these two containers completed task, then only this will get created, right? Otherwise it will be just waiting. So what it will here, it will happen that actually that it is in a wait state. Even if you come over here, and if you come down here, you could see that there is one command, the logs actually. See kubectl logs, right? If you just copy paste this log, see, copy paste this command, and you just execute this command. See what it is doing. The first service, it is waiting for the service to be there, but what it says, it cannot resolve that service. It is unable. So ns lookup, it can't resolve the service. So for this one, it is waiting for that service, sir, actually. See? For this one, for this, it is waiting for this service, sir. So there is no service at all. That's the reason in the logs also you could see that it is throwing as a ns lookup can't resolve this. Similarly, if you come here and if you copy this kubectl logs of the next container, right? I'm just copying this line, the command, and executing here. Okay. What it says that waiting to start actually. It is a pod initialize actually, right? So it means that it is not even started also. It is just waiting. It means that even though even this container also has to do some kind of a ns lookup or some service, but this is not yet even started because this itself is not completed. How this can start? So this will be in a waiting state. Even this will be in a waiting state. So now what happened, right? You need to create a service where those service, you need to create a service where it can look for the service for this container, as well as you need to create a service where you have to look ns lookup for this service actually. So to do that actually, if you come down here, you have a service. See, you have a service for the my service, you have a service for the my db actually. See, so you can copy paste this. So here what you can do, go here and you can say that vi service something service.yaml. I'll paste it here like this. Okay, I'll just say kubectl. So just observe, sir, what will happen. See, we kept for it. Okay, now you could see that kubectl apply -f service.yaml. See, as soon as the service get created, see the service get created. See, this will get started. Say this will go off, and the pod will come into the running state. See, pod is initialized, both the pods, and now what happened, right? See, this will come to the running state. Now, if you see the kubectl describe pod and specify this pod name. Now you see the description, sir. Now you describe and now you check it out. So I'll do one thing. I'll say pipe it to less. So now you could see that actually, sir. Now you could see that within your pod, you had a init container. Within the YAML file, you had a init container. See what happened, right? It was looking for some service. It got that service and it got terminated. Means this init container, this first service got terminated. Come down. See, when it got terminated, sir, you could see that it started at 14:59:11 seconds, but it got finished with 14:04. Why? Because as soon as I run the service.yaml file, it got that service and it got terminated. After this, you come down here. See, your second service. What is the second service? Your second service is what? Init-MyDB. See, it got created. When it got created, see, at the same instance, see, after 32 second, right, it got created. And it got terminated because it got that service, right? It was looking for the service. It was doing some NS lookup for the service. Oh, it got that service because the service is already there. See, the service already got created here. Oh, it was looking for that service. Fine, it got it. See, it got terminated there itself. It means that within a fraction of second, it got terminated. See, after this, you come here and you are having your main container, which is now my app, right? So if you go here, see, this is your main app, main container actually. See, my app container. So what happened right here? What happened? See, it is up and running. So when it got started, see, this got terminated 15:04:32. See, this got started at 15:04:33. So now you can understand very clearly with this flow that actually first always the init container will get started and it has to get terminated. Once it gets started and get terminated, then only your main container will get started, sir. Correct, sir? So with this example, you can easily come to know that what is the usage of the init container, right? The usage of the init container is that always it has to do some kind of pre-checking. It does the pre-check. If that particular service is there or not, if that particular container is it's already up and running, then it will allow to create the main container, or else it will not allow to create at all. Clear, sir? So similarly, if you come down over here, you can go through this article, it's a very nice article. So if you come down over here, actually, it will give a detailed behavior of how exactly things works actually. But if you come down here, you can even create one more example, sir, creating a pod that has init container. See, this is some real-time example, sir. Now, what is this real-time example? See, if you see it here, if you check it here, let me do one thing. Let me copy this. Copy it. So I'll do one thing, sir. I'll say kubectl delete -f init -container.yaml, right? I'm deleting it. Okay. Okay, why it's taking so long time? Yeah, it got terminated. Okay. I think I have to remove the same stuff. All the things have to remove. So this is one real-time use case of the init container, sir. So what will happen if you see here? Now here what happened, right? Under the container, you have one. Under the spec, you have a container. You have a container with the name Nginx. Okay, it is using a port number 80, and here it is using the volume points, volume mount point. So right now we have not come to the volume, but just try to understand that it is using some volume mount point, and the name of the volume is workdir, and the mount point of that volume is /usr nginx html. Okay, it means that this nginx pod, okay, this path, right, /src, it has been mounted to some volume actually. Okay, it has been mounted to volume. And now if you come over here in the down, here it has some init container. Okay, and the init container here, what is happening that you are having one container, okay, with the name install, okay, and it is using the image of busybox, and here it is a command. What it is using the command means it is using a wget actually. It is using the wget of this file actually. It is some file and this content of the file, it is actually writing into this index.html file, which is actually there under /work_dir. So what wget is doing, it is copying the content of this file and it is copying and it is placing under this index.html, which is there under /work_dir. And here also it is using the mount volume. So it is using the volume name as work_dir, and the mount point is /work_dir. That's what it is using here, /work_dir. Under /work_dir, it is creating the file with the index.html, and what are the content which is there in the site, right? That is getting copied here. And here, if you are having a DNS policy as default, we will discuss what is this DNS policy later. Now, if you come down here, you have defined your volume, sir, at the down. So you are creating a volume with the name work_dir as a volume name, and the type of your volume is mtdir. So we will discuss separately. We have one session on volume itself. We will discuss that later. But right now, what happened within your YAML file or within your pod, you are trying to create a volume, and that volume. So here, what the init container is doing, basically init container, once you run this YAML file, what the init container, first this will get executed. What it will do, it will try to copy the content of this HTTP into this index.html. So now what is happening? This what will happen, that this is going to, so the same file, right? It has been mounted to the /user nginx HTML, right? Actually, right? So what happened, right? For the nginx, it always expects this file to be there under this path, actually. So this is what it is. So now when I do a kubectl apply f and specify that init container YAML. So now you could see that actually that it has created. See, it was waiting for that init container got executed, and then finally the pod came into running. So here also, if you do a describe kubectl describe pod, specify the pod name, that init-domain demo. Sorry, if you come down here, see this, you could see the events, what and all things it did. See here, you could see that what happened, right? It started the installer. So under the install, it is pulling the build image, and it started it, created it, and later what happened? This got completed, sir. And then what happened? The nginx got created. Okay, it got pulled actually, and then the nginx has started. So nginx is up and running now. So if you go up here, the same stuff. See, under the init container, you have a name as install, right? So here, same thing. You have a name by name install. See here, the install. The container name is install. So what it is doing, it got terminated, but what it has executed this command, sir, actually. So when it got created, see, 15.11.44 got created, 15.11.45 it got terminated, finished. After that, you could see that your main container, nginx container, see, when it got created, sir, 15.11.46, exactly after this, it got created, sir. And it is running, up and running. See, it is up and running. See, this container is running, whereas the init container, it completed its job and it got terminated. So this is also one of the real-time example to just showcase how init container works. Clear, sir? Okay, so today we have finished these things, and in the next class, right, we would be concentrating on the multi-container pod and Kubernetes volume chart. If these two completes, we have completed almost 60 to 65% of the Kubernetes. After that, we have all small topics we are having. So whatever in our WhatsApp message I have mentioned, right, all those topics are very, very small topics. Every topic is around 10 to 15 minutes. Like in one session, right, we can cover some 4 or 5 topics we can cover actually. So, but our main thing is that actually we have to understand about the troubleshooting topic, as well as we need to understand, we need to give some time on EKS, sir, Elastic Kubernetes Service, that is AWS Elastic Kubernetes Service, as well as Kubernetes Helm. Istio I will see, sir, Istio as well as the service mesh I will see it, because service Istio is not, but it is a networking stuff itself. Well, what are the English load balancer type we have, right? There is one more type now with the name Istio. I will see whether we'll be able to take or not. We will try to take it maximum. Service mesh also will try to take it maximum. So Helm, but of course Helm we have to cover this one. It's very important. After that, we need to have understand about the Kubernetes integration with Grafana and Prometheus and Grafana. This is very, very important, sir. A lot of places they are asking this one, as well as ELK, Elastic Log Stash Kibana. So these are the upcoming topics, sir. Okay, means this we will see at the after a few sessions, 3-4 sessions, we will see this. But there are many other sessions are there which we will be discussing, right? Like we have a probes, we have a affinity, we have what is RBAC, right? Many of the topics are there which we have to cover. After that only we will be coming to the troubleshooting and all. Clear, sir? This is what our journey would be, and hopefully that we would be completing by at least by end of this month, or else by February first week we'll be completing, sir. We'll complete this Kubernetes. Okay. Okay, guys. Chalo then. I think some of you can stop the session.